Hello, my name is Pcholkina Mariia, and now I'd like to introduce you my work, Methodology of Prediction of Properties of Radio-nuclides. The purpose of the work is to study and to predict the dependencies of the main characteristics of nuclides, being energy and half-life time, on the nucleon composition, that is the number of neutrons and protons in the nucleus. My topic is so important because it can be a significant step in the understanding the forces that act in the nucleus. And it can also refine some theoretical models and explain the processes that nuclear physics studies. Understanding the forces that act in the nucleus is fundamental to the transition of science to a new stage that will open up new horizons for humanity. The important fact: the International Atomic Agency highlights 9 United Nations global goals out of 17 that can be achieved by using radioactive materials. And the first step of our work is the selecting of the main characteristics. We selected such characteristics as nuclear mass, mass defect, and half-life time. These characteristics are so important because knowing of their values makes it possible to know the amount of energy and the decay time to obtain the most important parameters for practical applications. The second step of our work is the investigation of the dependence of the half-life on the defect of masses. First, the dependence was investigated for some elements from 50 to 95 element. The graphs on the left part increased and dropped down very sharply, so we can see some rapid ups and downs. But graphics in the left part of the illustration are just gradually climbed, so they are very different. We decided to research how exactly this breaking of properties of graphs happens. We built such graphics for elements from 80 to 85. This illustration depicts a very unpredictable result, a bright transition on the border of element 84, a blue graphic. Such a pattern will help to understand how the nucleus is arranged and by what forces it is held. The third step of our work is the investigation of the dependence of the mass defect and half-life time on the composition of the nucleus. And firstly, we built graphics of the dependence of the mass defect and half-life time on the number of neutrons. Then we corrected these graphics by adding some coefficients to the number of neutrons. Now you can see corrected new graphics on the screen. We described these graphics by some mass equations. There it is. The first mass equation is for defect of masses, and it can be used for all elements. The second is for a half-life time, but it can only be used for elements up to 84. So, the conclusions. In the work, the change of properties at the border of 84 element was studied. Such a pattern will help to understand how the nucleus is arranged and by what forces it is held. Two mathematical equations have also been determined that allow the mass defect and half-life to be determined from the nuclear composition. These equations will make it possible to calculate the most important characteristics of decay, the energy that will be realized and the time in which decay will happen. Certainly, there is a margin of error in the expression that helps to predict a half-life time, but it helps to determine the order of magnitude, which is so important when dealing with nuclear decay time. Such forecasting will be useful in various life sectors, in medicine, energy, astronomy, and even in the agriculture sector.